Is it okay now?
Yes, sir.
Okay. So what are lenses? You have studied in your class 10th also. It is a refracting medium
Hello,
bound,
sir.
bounded by
Hello.
spherical surfaces.
Priya. Priya.
Spherical surface.
Rani.
Beta, I am making one of you as a host, so please remove all of them.
Okay, sir. Make me.
Okay. Okay.
Okay, sir.
Bounded by at least one, at least one spherical surface. Okay. So it is a refracting medium which is bounded by at least one spherical surface. Have you got this? All of you can see this?
Yes, sir.
Okay. There are different types of lenses. Or you have seen how many types of lenses you have seen? Spherical or curved surface. What you can call curved surface. Spherical or curved surface. Have you got this? So there are two types of lenses. In on the broader side, you will see what are those. Otherwise, there are 6 types of, but some of them are converging, and second is diverging. Okay, these are the two categories. So what are converging lenses? Which convert the light after refraction or bend the light towards the principal axis after refraction. Okay.
Sir, what if you fuck me?
After refraction. And these are the lenses which bend the light away from the principal axis. Have you got this, beta? What they are? All of you can see this now? Okay. So there are in this category there are 3 lenses. In this category there are 3 lenses. Then total there are 6 lenses. So what are those in this category? First is convex lens. Okay, what kind of it is? It's somewhat which is being bounded by two spherical surfaces in this where it is thin at the edges and bulge at the middle. Have you got this? Second one is plano-convex. How it looks like? It is plano-convex or in which it is being thin at the edges and also bulge, and one side is being flat. Okay. Then third is a concave concavo-convex. Third is a concavo-convex. It would be like this. If you see. Okay. Can you see this? Can you see this part? It is somewhat like this. This one. Okay. Here it is being named, if you see, concavo-convex. What does it mean? Concavo-convex. What kind of nature this lens will show? Whether it will show a concave, a converging lens, or as a diverging lens. We have seen that we have written it in the converging lens part. So it will show as a its total overall nature will be as a convex lens, means converging lens. Have you got this? Have you got beta? There are three types of lenses. What kind of nature they are having? Converging. Okay. Similarly, there are concave lens. What kind of shape it is? All of you knows. It is like this. Have you got this? Where it is thick at the edges and thin at middle. At the middle, it is thin and thick at the edge. Second one is plano-concave. What kind of it would be? Plano-concave. It is somewhat like this. Have you got this? This is plano-concave. So it is convexo-concave. Plano-concave will be yes, it has one side flat and other side somewhat like this. Like this. Have you got this? This is plano-concave. Third one is convexo-concave. Convexo-concave. Okay, what kind of nature it is or shape it is having? The previous one that I have drawn like this. If you can see that. Huh? Okay. Instead of here, I am making it over here. It is somewhat like this, where it is having this side as a convex and this side as a concave. Overall nature is being concave, diverging. Have you got this, Vita? Okay. Can I rub this, or all of you noting it down? Can I rub this?
Yes, sir.
Okay. So there are some terms related to the convex lens or lenses, like focus, center of curvature, radius of curvature. That are all you know. As you know, there are two cut surfaces. There are two cut surfaces. So for the two cut surfaces, they are having two center of curvature. This means two radius of curvature. This means two focus. Okay, so let me do this first focus. Which point is said to be the first focus? It is the focus of which the light rays are coming parallel to the principal axis as said to be converged. Okay, have you got this? The first focus is said to be the point where the light rays from the infinity are coming parallel to the principal axis, get converged like this. It is converge at this point. This is his first focus. Have you got this? Similarly for okay, but I am not the
Done, sir.
host.
Done, done.
No.
I didn't see.
Done. Okay. For this, the lights are coming parallel and get diverged. For this is seems to be the first focus. Okay. Second focus, if the object is at this point, the image get formed at infinite. That is called second focus. So for the convex lens, let us say this is the point. The light rays are going from there. It get parallel to the principal axis, so the image get formed at infinite. This is called second focus. Have you got this? Have you got this, beta? Oh, sorry. It has been like this, not the, this is the first focus. This is the first. That's why for this, the focal length is for this concave lens, the focal length is negative, you take. Okay. Have you got this, beta?
Yes, sir.
This is the point where after uh, if the object is at this point, the rays get parallel to the principal axis. If the object is at this point, it would be at this side. So the light rays which are going parallel to the principal axis after refraction, it will be the imaginary point over here because we are not in a condition to draw this. Okay, have you got this, beta? For the second one, the light rays okay, let me see. Now, lens maker formula. We have did in class B6. Okay. We have did in class B6. It will be a revision for all of you. Lens maker formula. What does it mean? What will be the focal length you will decide for a lens? So as you know, it is a combination of two spherical surfaces. Lens is a combination of two spherical surfaces. Let us say this is object at point A. So for drawing the image on this side, we should need the two rays. Okay. One is passing through the optical center, which is the ray which is passing through the optical center, it pass undeviated. Okay. And the light ray which is being incidenting at this point over here. If you see at this point, it will bend towards the normal, away from the normal. If NM and L is the refractive index of the lens, and NM is the refractive index of the medium, and NL is greater than NM. Okay. So tell me in which direction the light ray get bent at this point. Huh? It will bend towards the normal. Yeah. So at this point, this is the first refraction that is happening at the first point. At the second point, when the light reaches to the second surface, second curved surface, spherical surface, and at this point, where the light get bent, where will be its normal? Somewhere over here, and it will bend away from the normal. So the image, oh sorry, it is getting towards the normal. Away from the normal, the image get formed at this point. Okay. This is R1. This is R2. If you say this is object distance. Okay. This is if this second curved surface were not there, the image, the first one, get formed somewhere over here. Let us say it is V dash, and the final image is at V. You can see all the things, all the parameters you can see, that we have taken. Okay. So for the first reflecting surface, we have seen reflecting if the spherical reflecting surface is there, what kind of refraction is happening for the first case. For first reflection through first spherical surface. Reflection through first spherical surface. What do we need to write? If you see, this is the object distance. What R we need to take for the first spherical surface? R1 or R2? What was the formula? Formula was N2 minus N1 upon R is equals to P minus N1 upon U. This was the formula. If we use this formula, where the image get formed, what we can write for the first spherical surface? Which R we do need to take? No, R1. Because this is the first spherical surface, and for this is the radius. Okay, and light is entering from medium to lens. Then NL minus NM upon R is equals to NL upon where the image for this spherical surface get formed at this point. Let us say it is I dash. Okay, the image get formed at this point I dash. What will be the image distance? V dash minus Nm upon U. We can write this for the first spherical surface. Have you got this, beta? Now for second spherical surface, reflection through second spherical surface. Reflection through second spherical surface. What do we can write? Refraction through second spherical surface. If you see for the second spherical surface, this one, for this one, this I dash act as an object. I dash act as an object. So V dash will be taken as object distance. Can we take V dash as an object distance over here? Have you got this? I dash. This I dash is like an object for this curved surface. For this curved surface, this will act as an object, and the image for that is it is being formed over this at this point. Have you got this? Now what we can write? And the light is going from lens to air. Light is going from lens to air. Then what we can write? Nm minus Nl upon R2. Now for this is the radius. R2 is equals to Nm upon V dash minus NL upon V Nm upon V dash. You can write this. M upon V or NL upon. We can write this where the light is going from lens to the air. Then the here N2 is the refractive index of the refracting side of medium of the second medium. It was for the first medium. First medium means from where the light was coming. Second medium where the refraction was occurring. Okay, similarly the refraction over here we are taking in the first in the medium, and the light is coming from the lens. So this is our second medium, this is our first medium. So we have taken accordingly this formula we have right. Have you got this, beta? For this surface, the I dash act as an object because for this surface, the light ray is being bended towards the normal after reflection through this surface, and it will lead to be that the light ray is coming from it. Have you got this, beta? Okay, the light ray from this first surface bend towards the normal, and due to which this light ray at this point, refracting at this point, second one from the second surface, is appears to be coming from here because it is going in this direction. It is going in this direction. It is where it will intersect the principal axis. That point is said to be the image. So it is coming, looking like, because it is like a concave side. Okay, so it is looking like that it is being, this is light ray which is coming from here. It is being coming from this point. After hitting, if this light ray is being in this direction, so at this point, second point, the refraction is occurring through the concave part of the curved surface. Okay, due to which it appears that the light ray is coming from this point or going at this point. Have you got this, beta? After refraction at this point, this is the normal. This is C2, this is C1. The light ray is entering from lens to air or whatever the medium. This is the condition for that medium. The light bend away from the normal. If the light ray gets bent away from the normal, it will intersect at this point. But for this refracting surface, the image was there, or object was there, which is being imaged for this refracting first refracting surface. Have you got this? Okay, for on the basis of that, we have write the refraction through spherical surfaces. What do we have write for the second one? That the light is entering in the medium from the lens, then Nm minus Nl upon R2 is equals to where the image is forming in the medium. So Nm upon V minus Nl upon V dash. From where the image was light was coming from the lens. That's why we have write NL upon dash. Have you got this? So this is our first equation, you can say, and this is our second equation. Can we add both of them? Add both the equations. Add 1 and 2. We get, what do we get? Can I rub this? This part I am rubbing. So on adding these two equations, what do we get? N NL minus NM upon R1 minus, if we put it through sign convention, this is correct. Okay, but this get minus. Why? No. This R2. Okay, put it. See, first we are writing upon R2 equals to. These two terms are same in this one and this one. They get cancelled out on adding. This is negative over here and this is positive. These two terms get cancelled out in this on adding. What do we get over here? Okay. We are not putting it through sign convention. Forget it. We will put in at last. Okay. Now, if we take minus common from this, what we can write this? Can we write this in this form? And nm take common from here. Can we write this in this form? Have you got this, beta? We have taken minus common from here. We have taken minus common here. Then it will become NL minus NM upon R2. And NM common from there, that it will become like this. Have you got this? Okay. Now, if we take NL minus NM common from these two, what will remain inside R2 is equals to NM 1 by V minus 1 by U. Okay. Now, if we take NM common from here, M common, NM, then it will become NM NL minus NM minus 1 by R1 minus 1 by R2 equals to NM 1 by V minus 1 by U. Can we write this? NM NM get cancelled. Okay. Yeah, focal. Okay. Then what we can write this term? What we can write this term? Refractive index of the lens with respect to the medium. What we can write this? Refractive index of the lens with respect to the medium. Okay. So NLM minus 1 by R1 minus 1 by R2 is equals to 1 by V minus 1 by U. We can write this. If you're getting this now. Okay. Now, let us say that if for this lens, the object is at infinite. So object is at infinite, then image get formed at focus. We have seen this is V, which is equals to F, U is equals to infinite in this case. U is equals to infinite in this case. If we put these two values over here, over in this equation, over here in this equation, what do we get? This will become equals to 1 by F minus 1 by infinite, which is being equals to 1 by F. Okay, so the equation will become, can I rub this? The equation will become NLM minus 1 by R1 minus 1 by R2 1 by F. And this is lens maker formula. Lens maker formula means because lens is bounded by two curved surfaces, this lens or any curved surfaces, then it will become like this. Okay. What kind of focal length you have to choose? If you know the focal length of any lens, you can calculate its power, its image formation, all the details you can get now. It's called lens maker formula. Okay. By using this, its refractive index and what the radius you have chosen, according to that, you can select the focal length, desired focal for a lens. Okay. Have you got this, beta? Okay. Can I rub this? Yeah. To add for desired focal length of lens, we can adjust these two and this one, refractive index. It depends on both. That's why you see it is the lens lens focal length with respect to the medium. It is not fixed. If you dip a lens into any other medium, let us say if you are not, it is not in air, it is in water, then its focal length get changed, because at that time you have to use the refractive index of the lens with respect to the water. Have you got this? Then the focal length of the lens get different. Okay. Even converging lens may behave as a diverging lens in another medium. It depends on this. Have you got this? Convex lens may behave as a concave lens in another medium. Have you got this? Yeah. Okay. It is going to be end now.